Alright, hi guys. The first thing we'll be going over is runoff and eutrophication. So runoff is a part of the water cycle in which, due to differences in elevation, water goes downward, right? This is how when mountains, snow forms, it melts, it goes downwards, you create rivers. That's how that happens. So yeah, runoff. Owen's looking at me right now and he's judging me. It's really embarrassing. Runoff. Is that visible? Yeah, okay, runoff. So, we have fertilizers, right? And fertilizers have 3 main nutrients in them. I'll use a marker that's a little darker so you can see better. N, P, and K. Now, you're like all freshmen, so I don't know if you know the periodic table yet, but nitrogen, phosphorus, and potassium. The K is potassium. Those are our 3 main nutrients in fertilizer. Every fertilizer you see, if you look on the bags, it'll be like 30% nitrogen, 30% phosphorus, 30% potassium. That equals 90, not 100, but ignore that. But yeah, so for our purposes, we'll be focusing on these 2, nitrogen and phosphorus. Now, if you'll remember correctly, nitrogen and phosphorus were 2 of the cycles we had you learn. So, better have learned them, or else Owen is going to do something to you. I don't know. He's smiling right now. I don't know what he's going to do, guys. Be careful. But yeah. Sorry. So, nitrogen and phosphorus are 2 nutrients found in fertilizer. And when runoff happens, due to differences in elevation, so let's say I have cropland up here, and I fertilize it, and then I have a lake down here. Now when it rains, what happens? My water comes down here. It goes down here. So then also the nutrients in the fertilizer go in the lake. Now you might be thinking, isn't this a good thing? We're getting nutrients in the lake. No, it's not a good thing. Because there's too many nutrients. Nitrogen and phosphorus are both very important nutrients for aquatic life and life in general, but too much of them in excess is never a good thing. This is because, especially in lakes, what happens is that too much nitrogen and phosphorus can cause algal blooms. Oh, is it algal blooms or algal blooms? Do you know?
Algal.
Okay, algal blooms, right? So because of all this extra nitrogen and phosphorus, I have an excessive amount of algae, huge amounts of algae, right? And then all my dissolved oxygen in the water. There is oxygen in the water, by the way. Fish need oxygen. It's just in the water. The fish don't not need oxygen. So all my dissolved oxygen is taken up by the algae. Then what happens to everything else? If there's no oxygen, it dies. And this algae is such a thick layer covering the entire top of the lake that everything underneath it, all my aquatic life that might be underneath the lake, it all dies too. Now this is what's known as, I think this is a big word. Okay, I don't know if you can read that, but this is what's known as eutrophication. And this, if you ever did water quality in middle school, if you ever did dynamic planning, if you ever did green generation, and every single ecology or science event or environmental adjacent or science event, you will see eutrophication. This is a very important term to just know in general because people love putting in their tests. The sister terms to this, which are less likely to ever see, are oligotrophication. I think that's how you spell it. If it's not, my bad, guys. Oligotrophication and mesotrophication. You can find diagrams of each of these online, but oligotrophication is basically where you have too little nutrients, everything dies. Mesotrophication is when you have a relatively normal amount of nutrients, everything lives. I wish I could put Owen in an oligotrophic solution. Yeah.